Welcome to the video. My name is Chanin Nantasenamat, and I'm a Senior Developer Advocate at Snowflake on the Streamlit team. And in this video, I'm going to show you how you could build a machine learning application using the Streamlit library. And so without further ado, let's dive in. So before we begin and build the application, let's take a step back and take a high overview look at the typical machine learning workflow. So as you can see in the illustration here to the right, you're going to start with an initial data set. And then from there, you're going to perform data processing, like data cleaning, data curation, removing redundant features until you get the pre-processed data set. And from there, you're going to split the data into a training set and into a test set. And for the training set, you're going to use that to build your predictive model, which is shown here in the trained model. And then you're going to extract predicted values and also evaluate the model performance. And the metrics that are used for a classification model are, for example, the accuracy, the Matthews correlation coefficient. And for regression is R-squared and root mean squared error. And also, based on the predictive model, you can also extract useful insight from the feature importance. So what is Streamlit? Streamlit is an open source Python library that allows you to add a user interface to your Python scripts. So this means that your existing data scripts created in Python could be easily converted into a web application in literally minutes. And so all of this requires no front-end experience, and you can use pure Python. To get started, you want to install Streamlit into your computer. And in order to do that, you could use pip or also conda. And when you're using pip, you could do pip install Streamlit. And in order for you to update your existing Streamlit version to the latest version, you could do pip install -- upgrade Streamlit. So let's take a look at the rule of thumbs for building a typical Streamlit application. So generally, the first thing that I do would be to scope the general theme of your application. For instance, you could make a list of the features or wish lists that you want the app to do. And based on these lists of features, you're going to determine what is your input and what is your output. And also, you want to also have some ideas on how you could transform or process your input into the output. And finally, the last step is to actually build the app, and then you could refine the app and improve it later. So let's take a look at the app that we're going to build today. It is the simple prediction app that we're going to make use of the iris data set. So you can see from the left-hand side here, there is the input features that will accept user input on the 4 characteristics of the iris data set. And then based on these input features, it will be used as the X variable from which the trained model will make a prediction on. And finally, the predicted value will be displayed at the bottom of the application, shown here by the versicolor label. You could also check out the demo app and play with it yourself by scanning the QR code. So as already explained, this is an overview of the application in a cartoon illustration. So the left-hand side here will provide you the input slider widget, where the user could slide the widget and it will dictate the value for each of the 4 input features. To the right-hand side, it is the main panel where the EDA or exploratory data analysis is performed. And then the prediction will occur and the predicted result will be displayed at the bottom of the main panel. All right, and so let's get started. And here are some prerequisites that you will need in order to create your app. So you would need Python 3.9 and above. You would need to have pandas installed and also scikit-learn. And then finally, you could also share your app to the cloud using Streamlit Community Cloud. Let's have a look at the contents of the ML app. So you could go to Data Professor on GitHub/simpleprediction, or you could also scan the QR code or go to the specific URL provided on the slide. And in a nutshell, you're going to see that the repo will comprise of the config file, .toml, the README, which will be shown on the main page of the repo. There's the requirements.txt, which will provide the required Python library that the app will need. And finally, the main Streamlit app file. So at a high level, the app file will comprise of about 60 lines of code. And so it will, in a nutshell, import the necessary libraries, set the page configuration, print out the title or the header of the application, load in the iris dataset, define the slider widget, and on the lower part of the code, it will perform data processing of the data frame, and then it will use that as input to the random forest model where predictions are made. And finally, it will perform exploratory data analysis to provide a glimpse of the data. And then the input features will be used for making predictions, and the predicted label will be provided on the bottom part of the web application. So this is the requirements.txt. This is the configuration file. It allows you to style the page color. And here are the links to the application. All right, so what you want to do now is fire up your terminal or command line. And I'm going to show you from scratch. So the first thing is you want to create a Conda environment. Conda create, name, and then we're going to specify, for example, iris. And then we're going to specify the specific Python version, and we're going to use 3.10 here. And it's going to ask whether to install the prerequisite libraries. Enter yes. So in the meantime, grab a cup of coffee, and in a short moment, all of the libraries will be installed. All right, so it's installed, and you want to activate the environment. So you want to do as is specified here. So type in conda activate iris. And then we want to install Streamlit. So pip install Streamlit. All right, and now we're going to install pandas. Pip install pandas. It already has it. Pip install scikit-learn. All right, and I think we're good to go. So we're going to create a app file, Streamlit app.py. So here we're going to create an app file using Vim. So I typed in Vim and then the name of the app, which is Streamlit app.py. And you want to hit on the I key, which will bring up the insert here. And then you want to type import Streamlit as st. And then let's do Streamlit write hello world. Make sure the application is working properly. And hit on colon WQ to write and quit. And then you want to type in Streamlit run Streamlit app.py. And in a short moment, the browser will pop up showing you the application. So for the first time, you want to enter your email address here. All right, congratulations, your app is up and running. And so as you can see here, the browser will load up your web application, and it's running here from the localhost on the 8501 port. And so I'm going to show the application side by side with the code. So I'll open up another tab here. Working directory. Going to the sandbox. In the Streamlit app.py, I'm going to edit this file. All right, and so hit on I in order to insert your text here. So I'm going to import pandas as PD from sklearn.model selection, import train test split because we want to perform data splitting. We're going to import the random forest classifier here from the scikit-learn library. And here we're going to specify the page configuration. We're going to set the page configuration here. Layout to be wide. And we want to have the default sidebar to be expanded. And here we're going to specify the title of the application. Using the sttitle command, simple prediction app. We're going to load up the data set using pandas and assign it to the df variable. And the data will come from the GitHub repo, GitHub user content.com/data professor, and it's in data master and iris.csv. So before continuing further, I'm going to write it out and I'm going to save it. Let's have a look. And the app will ask whether we want to refresh it, and we say always rerun upon change. All right, and so you can see that the app has already updated and it's displaying the iris dataset that was retrieved from the GitHub repo. So let's continue to edit the app. So we're gonna take the data frame and we're gonna add some input widgets as well. So input widgets, and then we're gonna put it to the sidebar, the subheader, input features. We're gonna create 4 slider widgets, and we're gonna assign it to variables comprising of the sepal length, slider, sepal length. We're going to specify the minimal value, the maximal value, and the selected default value. Sepal width, st sidebar, slider, and sepal width, 2.0, 4.4, 3.1. Middle length, the sidebar, slider, middle length, 0, 6.9, and 3.8. Finally, the 4th one is the petal width. Petal width. And we're having the minimal value, maximal value, and the default. And so here we're going to perform data splitting to the x and y. And we're going to define the x variable, and we're going to do df.drop. We're going to drop the species column because species column is the y variable. We're going to specify axis equals to 1 because we're working with the columns. And we're going to define the Y variable and select only the species column. Here, we're going to perform data splitting. And we're going to define 4 variables concurrently. Xtrain, xtest, ytrain, ytest. And we're using the train test split function. Input is the x variable, y variable. We're going to specify test size to be 0.2 and the random state to be 42. Right, and now the fun part is we're going to build the random forest model. So we're going to assign it to the RF variable using the random forest classifier command. We're going to specify some feature parameters here. You could also play around with this number as well. Random state to be 42. All right, and so we're going to then do the training of the model using RFFit. And we're going to specify the Xtrain and the Ytrain as the input. And then once we've trained the model, we're going to apply the model to make predictions. And to do that, we're going to create a ypred variable. And we're going to take the random forest model and then make a prediction. And then we're going to specify a data frame based on the input features from the slider widget that the user has specified. And we're specifying it here. All right. And so let's try and have a look. We're going to save it. And it's updated here. But you're going to see that the sidebar panel here has the input features. And to the right-hand side, we have the predicted results. So if I slide the input, you're going to see that the prediction has changed because the input features have been altered. And you could play around with this and see which parameter on which end of the scale will contribute to it being setosa, versicolor, or virginica. Okay, and so now we're going to go back to the code. So type in vim streamlit app.py, and we're going to go to the bottom part. Okay, so let's add some more code. Here we're going to perform EDA, and we're going to specify the subheader here. We're going to do a brief EDA. I'm going to explain it. The data is grouped by the class, and the variable mean is computed for each class. And then we're going to group by species and compute the mean. The df group by species mean c.right in order to print it out. And then we're gonna create a line chart. But before doing that, we need to also perform transposition of the group by species mean. Right, and now we're going to print out the input features that the user has specified from the sidebar. And then we're going to create the input feature variable, which is essentially a pandas data frame. we're going to specify the variables here. I'm going to specify the names of the column. Finally, we're going to write it out using st.write. And at the bottom of the code, we're going to print out the prediction labels and have the subheader displayed as well. And we're going to use the st.metric to print out the predicted labels. And the predicted labels is contained within widepred. And we're going to slice the first value. And we're going to leave the third argument here blank. Now we're going to save it. :WQ to save. All right, and you can see that the app loads immediately. And here we've added the brief EDA section, showing the brief EDA data frame here, which is essentially grouping by the species and then showing the mean value. And then based on this data, we've created a line chart, and they're color coded according to different types of flower. And the data frame here is showing the values that are selected on the sidebar menu. And then finally, you're going to see that the output section here will print out the predicted class label, which is here to be Setosa. And so, as you can see here, you have successfully built a machine learning application in Streamlit, and you could also add additional features to this particular application. Thank you for watching. Please also make sure to check out the Streamlit YouTube channel and also the documentation and forum. And if you found the video helpful, please also like and subscribe.
I've been using Snowpark, silly! It lets you build snowballs with confidence by removing data security and compliance barriers to production with consistent, enterprise-grade governance controls. Pretty cool, right?
Wait, what?
Frosty gets his own song. Why aren't we singing about Snowpark? The easy way to production for Python! Using pre-installed packages and automated dependency management and secure processing. How do we make that rhyme? Oh yeah! Speed! Woo! I built this myself. Nothing could go wrong. Oh no!
Ah! You didn't use Snowflake Snowpark! It's the only way to go! Woohoo! I'm going so much further! Eat my snow!